Today we're looking at solving logarithmic and exponential equations. When you're doing these problems, you always need to check for extraneous solutions. If you're looking at your parent function y equals log x, that original equation we've looked at that has a vertical asymptote at x equals 0, so your x values have to always be greater than 0. They cannot be negative, they cannot be 0. So if you plug the answer in, when you plug in your answer, if it makes your argument 0 or negative, then you have an extraneous solution. The first type of solving of logarithms we're going to look at is if both sides of the equation have a log with the same base and no constant. So if they both have the same base, there's no other random numbers floating out to the sides, no constants. Because the two logs are equal, you can set their arguments, that's the stuff inside the parentheses, equal to each other. So for instance, on our first example, we have log base 2 of 2x plus 3 equals log base 2 of 5x minus 4. Because those both have the same base of 2, we know that the 2x plus 3 has to equal the 5x minus 4. So we're going to say 2x plus 3 equals 5x minus 4. If we'd subtract 2x, we have 3 equals 3x minus 4. Add the 4 to the other side. Divide by 3. So we get an answer of x equals 7/3. You want to always come up, plug it into your equation, and make sure it's not going to make it 0 or negative. 7/3 times 2 is 14/3 plus 3 is definitely not a negative number. 5 times 7/3 is 35/3, which is much bigger than 4, so it again will be positive. And if you plug those both in, you'll get the same answer on both sides. So we know that 7/3 is our answer. The next type of situation we have is when you have more than one log or just one log and a constant. So you have another number out there that's not a part of a log. The first thing you need to do is to make sure you condense to where you only have one log. You only want to have one log on each side, have that set equal to your constant. So the log base something equals your constant. So you're going to have to do some condensing to get there. You're going to exponentiate each side by raising the base of the log as the base of your exponent. I call it that you base it. In other words, each side that was there originally is now going to be an exponent, and the base that you're going to add in is the same base as the log. So if you have a log base 3, you're going to raise both sides. You're going to give both sides a base of 3, and your log will now be the exponent, and whatever it equals will now be the exponent. We're going to look at an example here in a second. Again, always make sure you check for extraneous solutions. So this first example, we have 14 plus 2 log base 3 of 9x equals 20. Again, the first thing we want to do is isolate our log. So we're going to subtract the 14. So we have 2 log base 3 of 9x equals 6. Still need to get the log by itself. I'm going to divide by 2. That way we just have log base 3 of 9 equals 3. Now at this point, this is where you want to add in your base. You want to base both sides, or you want to take log base 3 of 9x and exponentiate it. You want that to become your exponent, because a base of 3 and a log base of 3, they'll cancel each other out. So we're going to take 3 to the log base 3 of 9x equals 3 to the third power. When you do that, the 3 and the log base 3 will cancel each other out, so you'll be left with 9x. The 3 to the third is just 27. So the base of 3 to the log base 3 cancels each other out, leaving you with just 9x. 3 to the third is 27, so you'll leave it there. Divide by 9, and you get an answer of x equals 3. Again, always check your solution. If you plug your x value in, you get 14 plus 2 log base 3 of 27 equals 20. It's still positive, it's not 0, so we're okay. You can type those into your calculator as well to make sure that you have the right solution. This next example is where a little bit more of the trick comes in. We have more than one log. So the first thing we're going to need to do is to condense. If you remember, they both have the same base. So when we have x plus another log, that means we're going to multiply their arguments. We're going to multiply the x times the x plus 2. That'll leave me with log base 2 of x squared plus 2x. I distributed the x to the x plus 2 equals 3. Now we have our log isolated equals our constant. To get rid of this log base 2, we're going to base it with a 2. So we've got 2 to the log base 2 equals 2 to the third power. Again, that base of 2 is going to cancel out your log base 2. So you'll be left with x squared plus 2x equals 8, because 2 cubed is 8. From here, we need to solve for x. When we have a quadratic, the easiest thing to do is to look and see if it factors. So set it equal to 0. We're looking for what multiplies to be -8, that adds to be +2, which would be x plus 4, x minus 2. Set each term equal to 0, so we get x values of -4 or +2. Don't forget to check your solution. This is where we really have a lot of trouble in not checking our solutions. If we go and we plug in that -4, if we plug -4 in, we get log base 2 of -4. Right there we have a negative. Also, if we check on the next term, we get log base 2 of -4 plus 2, which is also a negative. So we have negatives in our logs, which we know is not allowed. So -4 would be an extraneous solution. If we check the 2 quickly, plug in 2, we get 2. 2 plus 2 is +4. We're doing all right. Those are both positive, not 0. So our answer is just x equals 2. Really important that you check your extraneous solutions. Okay, the final situation we're going to look at is solving an exponential equation. This is when x is in the exponent. First thing you want to do is isolate the variable and its base. Again, your variable is going to be in the exponent, so you're really trying to get the exponent with its base all by itself. You want to use a log with the same base as the exponent when solving it. This is going to cancel them out. I like to call it logging it, so you're going to log it. So whatever your base is of your exponent, that's the base of the log you're going to use. In order to evaluate that, you're going to use the change of base formula, which the change of base formula says that for a log base a of x, that's the same thing as the log base b of x divided by the log base b of a. You're not going to really use a base for b. When you plug these in, you're going to use the log button on your calculator, which has a log base 10 built in. So if you want to know what the log base 3 of 5 is, you're going to do the log of 5 divided by the log of 3 on your calculator. That's how you're going to figure it out, which we'll do an example of that here in just a second. Remember, if you have a natural log, has the base of e, so if you have an exponent or you have a base of e and you want to get rid of that base, you're going to log it with a natural log. So natural log and e go together. Always on these ones, you're going to have decimal answers, or almost always. You're always going to use 3 decimal places when you round. So the first example we look at is we've got 3 times 5 to the 4x minus 7 equals 11. First thing you want to do is add the 7 to the other side. We're trying to get 5 to the 4x by itself. So add 7 to the other side. You get equals 18. Now we still want to get 5 to the 4x, so we're going to divide by 3. So we've got 5 to the 4x equals 6. Now here's where I need to get rid of that base of 5. I want to have just 4x so I can get x by itself. To get rid of the base of 5, we're going to log it. Since the base is 5, we'll use a log base 5. So we're going to log base 5 both sides. So now we have log base 5 of 5x plus 5 to the 4x equals log base 5 of 6. When I do that log base 5 of 5, that's going to cancel out my base of 5 and leaving with 4x. To figure out what log base 5 of 6 is, we're going to, in our calculator, hit the log button, do log of 6 divided by log of 5. You do log of the big number divided by the log of the base. The base always goes on the bottom. So when we do that, we end up with 4x equals log base 5 of 6 is 1.113 and a bunch of decimals. Again, store that number in your calculator. Don't round it, just leave it in your calculator. The last thing we need to do is divide by 4. So we'll divide by 4, and we get x with our rounding to the third decimal would be 0.278. Our second example uses an e, so we know if we see an e, we're going to end up using a natural log. So the first thing we need to do is get e by itself with its exponent. So we need to get rid of the 1/2, which is the same thing as we can multiply by 2. So we've got e to the negative 3x plus 2 equals 6. We want to get rid of that base of e, so we're going to natural log both sides. Natural log of e to the negative 3x plus 2 equals the natural log of 6. The natural log will cancel out the e, leaving us with just negative 3x plus 2. Using your calculator, the natural log of 6 is 1.7917. Again, it continues on for quite a while. Still need to get x by itself. Using that stored number, we're going to then hit minus 2. And you'll get negative 3x equals negative 0.2082 and a whole bunch of numbers. Again, leaving that in there. We're then going to divide by negative 3. So we end up with x equaling 0.069, and that's your answer. Now to plug these in and check them, you can plug your answers back into the equation and see if you get 3. You may not get exactly 3, especially if you use the 0.069 since there's some rounding in there, but it should be pretty darn close to 3. All right, we're going to do more examples and practice in class, so make sure you come ready to ask questions and get started.